Our solar system is a vast and fascinating place. It is home to a star, 8 planets, and countless other objects. But have you ever wondered how this incredible system came to be? Billions of years ago, our solar system was just a giant cloud of gas and dust. This cloud, called a solar nebula, was the birthplace of everything we see in the solar system today. The solar nebula was mostly made up of hydrogen and helium, the most common elements in the universe. But it also contained tiny amounts of heavier elements like carbon, oxygen, and iron. These elements were created in the hearts of stars that lived and died long ago. Over time, gravity began to pull the gas and dust in the solar nebula together. As the cloud collapsed, it began to spin faster and faster. The spinning motion caused the cloud to flatten out into a disk, like a spinning pizza dough. This spinning disk is where our sun and planets would eventually form. It's amazing to think that our solar system, with all its planets and moons, originated from a simple cloud of gas and dust. But the story doesn't end there. In the next section, we will explore what happened as this cloud continued to collapse and evolve. As the solar nebula continued to collapse, more and more material got pulled towards the center. This central region became incredibly dense and hot. The temperature and pressure at the center of the collapsing nebula became so great that hydrogen atoms began to fuse together to form helium. This process, called nuclear fusion, released a tremendous amount of energy. The energy from nuclear fusion caused the central region of the nebula to shine brightly. This bright, hot center would eventually become our sun. While the sun was forming at the center, the rest of the nebula continued to spin around it. The material in the disk started to clump together due to gravity. These clumps would eventually become the planets and other objects in our solar system. The story of how these clumps formed into planets is a fascinating one. We will explore this process, called accretion, in the next section. In the swirling disk of gas and dust surrounding the young sun, a remarkable process was taking place. Tiny particles of dust, no bigger than grains of sand, were colliding with each other. These collisions were gentle at first, but as the particles stuck together, they grew larger and larger. This process is called accretion. Over millions of years, these clumps of dust grew into larger and larger objects called planetesimals. Planetesimals were like miniature planets, some as small as mountains and others hundreds of kilometers across. These planetesimals continued to attract more dust and gas, growing larger and larger. As the planetesimals circled the sun, they interacted with each other through gravity. Some planetesimals collided and merged, while others were flung out of the solar system entirely. Over time, the largest planetesimals in the disk swept up most of the remaining material, eventually becoming the planets we know today. This process of accretion is fundamental to understanding the formation, not just of our solar system, but of planetary systems throughout the universe. As the sun ignited and began to shine, it released a powerful stream of charged particles called the solar wind. This solar wind blew through the solar system, pushing away the remaining gas and dust that had not been incorporated into planets. The sun's heat also played a crucial role in shaping the solar system. The inner region of the solar system, closer to the sun, was much hotter than the outer region. The intense heat in the inner solar system vaporized most of the lighter elements like hydrogen and helium. This is why the inner planets, Mercury, Venus, Earth, and Mars, are primarily composed of rock and metal. In the outer solar system, where temperatures were much cooler, ices made of water, methane, and ammonia could survive. These ices, along with rock and metal, formed the cores of the giant planets: Jupiter, Saturn, Uranus, and Neptune. The sun's gravity acted like an invisible hand, shaping the orbits of the planets and other objects in the solar system. It is the sun's gravity that keeps the planets in their orbits and prevents them from flying off into space. The rocky worlds of our solar system. These terrestrial planets, Mercury, Venus, Earth, and Mars, are composed mainly of rock and metal. They have solid surfaces, unlike the gas giants. Each of these planets has its own unique characteristics and mysteries. Mercury, the closest planet to the sun, is a world of extremes with scorching days and freezing nights. Venus, often called Earth's twin, is shrouded in thick clouds of sulfuric acid, creating a runaway greenhouse effect. Earth, our home, is the only planet known to support life with its vast oceans and diverse ecosystems. And then there's Mars, the red planet with its towering volcanoes and deep canyons, a place where we continue to search for signs of past life. These rocky worlds offer a fascinating glimpse into the diversity and complexity of planetary formation in our solar system. As we journey further, we encounter the giants of our solar system. These colossal planets, with their immense sizes and powerful gravitational fields, play a crucial role in the dynamics of our cosmic neighborhood. Jupiter, the largest of them all, is a gas giant with a mass more than 300 times that of Earth. Saturn, with its stunning ring system, is another gas giant that captivates our imagination. Together, these giants dominate the outer reaches of our solar system, influencing the orbits of other celestial bodies and protecting the inner planets from potential threats. Orbiting these giant planets are their natural satellites, or moons, each with its own unique characteristics. Jupiter's moon. Ganymede is the largest in the solar system, even bigger than the planet Mercury. Saturn's moon Titan is shrouded in a thick atmosphere and has lakes of liquid methane on its surface. These moons, along with many others, provide a fascinating glimpse into the diversity and complexity of planetary systems. Beyond the major planets and their moons, we find the leftovers of the solar system's creation. The asteroid belt located between Mars and Jupiter is a region filled with rocky debris. These remnants of the early solar system offer valuable clues about its formation and evolution. Further out, the Kuiper belt and the Oort cloud are home to countless icy bodies, including dwarf planets like Pluto. These distant regions are the final frontier of our solar system, holding secrets that scientists are only beginning to uncover. At the heart of it all is the Sun, the source of energy that sustains life on Earth and drives the dynamics of the entire solar system. The gravitational interactions between the Sun and the planets create a delicate balance that maintains the stability of our cosmic neighborhood. The Sun's immense energy output through nuclear fusion powers the processes that shape the planets and their atmospheres. Understanding these interactions and the Sun's role is key to comprehending the intricate dance of celestial bodies in our solar system.